We often hear that objectivity means detachment, a separation between the observer and the observed. But this common understanding is a shallow definition of what true objectivity entails. True objectivity isn't about complete separation, which is often impossible, but about something far more fundamental and practical. The real foundation of objectivity is consistent reproducibility, meaning that results can be reliably obtained multiple times. This reproducibility must be consistent within a specific context. Reductionist thinking often mistakenly equates objectivity with universality, assuming that if a theory is objective, it must apply to everything. However, objectivity is not global. It is inherently contextual. It depends entirely on how consistently results are reproduced within the specific conditions where the theory is designed to apply. Two experiments, even if separated by vast distances, can still share the same contextual structure. Distance doesn't matter as much as the shared context does. This principle helps explain phenomena like quantum entanglement, where the description is bound by complexity and shared conditions, not by physical space. Objectivity truly emerges from these shared contextual conditions, rather than from an elusive universality or strict locality. It's about the framework in which observations are made. A result becomes objective when independent observers, using independent setups, consistently obtain the same outcome under similar, well-defined conditions. This reproducibility inherently includes contextuality. The theory itself is merely a map, a compact way to describe that observed consistency. It doesn't create objectivity. Instead, it serves as a representation of what is already objectively true within its domain. Every theory, no matter how robust, has a boundary defined by its inherent complexity. Fields like quantum mechanics, thermodynamics, and relativity all operate effectively only within specific conditions. Beyond those established limits, it's not that the world itself fails to conform. Rather, our current descriptions and models simply cease to be adequate. They reach their descriptive capacity. For instance, when a quantum system interacts with a measuring apparatus, the complexity often exceeds what quantum mechanics can fully describe. This is why the so-called wave function collapse isn't a physical event. Instead, it marks the conceptual edge of the quantum map, indicating where our current theoretical framework reaches its descriptive boundary. New contexts inevitably bring new irreducible properties and necessitate new languages. Ultimately, objective is whatever can be consistently reproduced under similar conditions by independent observers. It's what remains stable and verifiable when tested repeatedly within the same contextual boundaries. Everything else, every equation, every model, every abstract concept, is merely the map, not the territory itself. The map helps us navigate, but it is not the reality. Objectivity is fundamentally contextual, not universal. Science, in its essence, builds a rich mosaic of truths, each valid and reliable within its own specific range of complexity. Being truly objective means recognizing and respecting these inherent boundaries, rather than denying them or attempting to force universal applicability where it doesn't exist.